Hello everyone, in this video we will study linear differential equation of first order and first degree, and we will solve some examples on this. Okay, so first take a look at the definition of linear differential equation of first order and first degree. The definition says an equation dy by dx plus py is equal to q whose left side is linear in both the dependent variable and its derivative is called a linear equation of the first order, where p and q are the functions of x only or constants. And the differential equation, this is also an equation which is linear, and p1 and q1 are functions of y only or constants. So what this means is that if we have this kind of differential equation, and from here it is clear that this differential equation has order 1 and degree 1 because dy by dx का order 1 है and dy by dx का power or you can say degree 1 है. इस differential equation में we have only one derivative, okay, one derivative term, and its order is 1 and degree is 1, so the order and degree of this differential equation is 1. Anyways, so this kind of differential equation dy by dx plus p, what is p? Here they said that p and q must be functions of x only or constants. So p, you can write p like this, okay, and similarly you can write q like this. Px means p is a function of x only, means px cannot be like e to the power xy because e to the power xy has y also. ठीक है, px में केवल x, कोई ऐसा एक्सप्रेशन होना चाहिए, कोई ऐसा फंक्शन होना चाहिए जिसमें केवल x हो या फिर कांस्टेंट हो. So p can also be 5, p can be 5 by 3, okay, p can be e to the power x, p can be sin x, like this. Similarly qx is a function of x alone, okay. Now so this is a linear differential equation of first order and first degree where y is dependent and x is independent variable. Similarly, this differential equation is linear differential equation of first order and first degree where x is dependent variable and y is independent variable. So because in this differential equation the independent variable is y, so here p1 and q1 are functions of y only or constants. ठीक है. Now we move how to solve such kind of linear differential equations. So here is the whole complete procedure how do we solve it, okay, but we will not read it, we just go to the working rules, okay, and I explain it for you, okay. So let's focus on the main steps. So if we have this kind of differential equation where p and q are functions of x only or constants, then the solution of this differential equation is given by this. This is the final solution of this differential equation, okay. And what is if here and what is c here? C is the arbitrary constant, okay, but what is if here? If is integrating factor where the value of if is this is if. It is written here that this is represented by if, okay. So this is what you all need to know, that given this differential equation, find if first, which of course will be obtained by integrate this p and put it in the power of e. So this will be if. Now put the value of if here and put the value of q here and solve this, and this will give you the final general solution of this differential equation. Okay. Similarly, if you have this differential equation where x is dependent and y is independent, then the जनरल सॉल्यूशन विल बी दिस. दोनों में डिफरेंस क्या है? इस इक्वेशन में जहाँ जहाँ x है वहाँ y रख दो, जहाँ जहाँ y है वहाँ x रख दो और वी विल गेट दिस. ठीक है. ज़्यादातर जो क्वेश्चन एग्ज़ाम में आते हैं वो इस टाइप के आएंगे जिसमें y हमेशा एज यूजुअल मोस्टली y डिपेंडेंट वेरिएबल ही होता है और x इंडिपेंडेंट वेरिएबल होता है. ओके. सो इस टाइप के क्वेश्चन ज़्यादा आएंगे. Okay, so now we do some numerical questions. So this is your first question. Consider this. Compare this differential equation with this. ठीक है. इस differential equation को इससे compare करो and you will see that अभी ये differential equation इस form में नहीं है because इस फॉर्म में होने के लिए dy by dx का कोफिशिएंट 1 होना चाहिए, बट यहाँ पर dy by dx कोफिशिएंट ये है. ठीक है. You cannot say like p is 2x and q is 4x square, यहाँ जाएगा तो plus 4x square हो जाएगा and q is 4x square. No, p is not 2x and q is not 4x square. Okay, because so इसको इस फॉर्म में लाने के लिए we will need 1 here. Okay, तो इसके लिए we will divide both sides of this differential equation by 1 plus x square. Okay, so we get dy by dx plus 2x upon this y is equal to 4x square right में चल रही है, so 4x square upon this. Now this differential equation looks like this. So we have this is p, okay, and this thing is q, and you can see that p is a function of x only, there is no y here. Similarly q में भी आप देख सकते हैं y नहीं है, q is a function of x only. ठीक है. So it is very clear that this differential equation now looks like this. Hence we will find the integrating factor, और एक बार integrating factor निकल जाएगा then we will put the value of integrating factor and the value of p and q in this formula. Where is the formula? This formula. Okay, so you have every time you solve these kind of differential equations, so repeat this formula every time. Okay, because ये formula आपको याद हो जाएगा. यहाँ पे इन्होंने repeat नहीं किया है but we will repeat it. So first we see what is the value of integrating factor if. So if is e to the power integral p dx. p की वैल्यू यहाँ रखी हुई है and we can see that this integral is very easy because when we differentiate 1 plus x square we get 2x which is the numerator. ठीक है. So the numerator is the derivative of the denominator. ठीक है. So इन्होंने यहाँ पर डायरेक्ट लिखा है, वैसे भी बहुत बेसिक फॉर्मूला है, everyone should know it. So integral of this is log of x square, log of 1 plus x square. How? Because okay, let's take a look on this integral separately. So let I is equal to integral 2x upon 1 plus x square dx. Okay, को कैसे करेंगे? Let 1 plus x square is equal to something, suppose u. So this gives us, on differentiating both sides, this gives us 2x dx is equal to du. So this integral I becomes integral 2x dx is du, so this becomes du upon u. This is log u. Put the value of u back, we get log 1 plus x square. Okay, so log 1 plus x square. But e to the power log 1 plus x square will be 1 plus x square because we know that e and log are inverse of each other. We know that e to the power log of some theta is equal to theta. Similarly, we know that log of e to the power theta is theta. Okay, so we have found the value of if. So hence the multiplying both sides by if we get, no need to write this, you can just simply write okay, wait a minute, Okay, now one more thing I need to say that यहाँ पर जनरल सॉल्यूशन निकालने के लिए इन्होंने ये फॉर्मूला यूज़ नहीं किया है, ये बेसिकली ट्रायल मेथड यूज कर रहे हैं, ठीक है. बट एनीवेज यू कैन, आई विल नॉट एक्सप्लेन दिस, you can, because since we are following this working rules, so we will use this formula for the general solution. Okay, so we have integrating factor 1 plus x square, and after finding the integrating factor we will write like this. The general solution of the given differential equation is given by dependent variable. Okay, dependent variable means y into integrating factor is equal to integration q into integrating factor. Remember that this is into, this is cross, not x. Okay, dx plus arbitrary constant. So as I said, always repeat this formula because this will help you memorize this formula. So now we will put the value of if, p and q. Okay, there is no p, so if and q. So this will become y into integrating factor, which is this. Okay, is equal to integration q. Q is 4x upon 1 plus x square. Okay, 4x upon 1 plus x square, and then integrating factor is 1 plus x square dx plus c. This will be cancelled and we will get y into 1 plus x square is equal to integration 4x dx. Okay, so the integral of this 4x dx will become 2x square plus c. So you can, okay, you can leave it here, no problem. You can say that this is the general solution, or you can like write it like this: 2x square plus c upon 1 plus x square. This is the general solution. This is also the general solution. Okay, this is the answer. Okay, I did a mistake here. It was 4x square. Fine. So the integral will become 4x cubed by 3. Okay, so you can write this is the final answer. It is also written here. Fine. So this is how we solved linear differential equation of first order and first degree. Let's do a few more examples. 1 plus x divided by dx minus this. Dividing whole equation by 1 plus x so that we can get 1 here. This will transform into this. ये ऐसे बन जाएगा, ठीक है. dy by dx minus this. p की जगह पे क्या है? माइनस एक्स अपॉन 1 प्लस एक्स, नॉट एक्स अपॉन 1 प्लस एक्स, माइनस भी है, ठीक है. एंड क्यू की जगह पे है 1 माइनस एक्स 1 प्लस एक्स. फाइन. सो वी विल फाइंड द इंटीग्रेटिंग फैक्टर. इंटीग्रेटिंग फैक्टर विल बी टू द पावर पी एक्स. पी की वैल्यू रख दी यहाँ पे. ओके, जूम इन. पी की वैल्यू उन्होंने रख दी यहाँ पे माइनस एक्स अपॉन 1 प्लस एक्स. ना इसका इंटीग्रल कैसे निकालेंगे? हियर यू कैन नॉट यूज़ दैट कॉन्सेप्ट दैट 1 प्लस एक्स को यू मान लिया, बिकॉज 1 प्लस यहाँ पे डिनोमिनेटर का डेरिवेटिव न्यूमरेटर नहीं है. ओके, सो in order to solve it you will have to write this like this. Okay, कैसे किया इन्होंने? बेसिकली इसको भी देख लेते हैं. let I is equal to minus x upon 1 plus x dx. so minus आप बाहर ला सकते हैं. it will become this. Okay, now x can be written like x plus 1 minus 1. Okay, why are we doing this? Because we want x plus 1 here. So this will become integral x plus 1 upon 1 plus x, means x plus 1 upon this means 1. Okay, and minus 1 upon 1 plus x. So this, so we have two integrals now. Integral of 1 dx is x, integral of this is log 1 plus x, so we get this. Okay, multiplying by minus 1 we this will give us log 1 plus x minus x. Okay, and so putting this, we get e to the power integral p dx. This will become e to the power this. Okay, e to the power log 1 plus x minus x, and further solving it, this will give us e to the power this upon e to the power this, to the power this upon e to the power x. Okay, e to the power this is what, 1 plus x upon e to the power x, means e to the power minus x. So this is 1 plus x e to the power minus x. This is the integrating factor, this one. Okay, so now we have integrating factor. So the general solution, not just the solution, general solution, remember, any solution which has arbitrary constant is called general solution. General solution of the given differential equation will be given by y into integrating factor is equal to integration of q into integrating factor dx plus c. Put the value of if here, this. Okay, put the value of q here and if here, we get this, ये cancel हो जाएगा, right hand side हमारा हो जाएगा 1 minus x e to the power minus x dx plus c. Now we need to solve this integral. So as you can see that जब भी वो डिफरेंशियल इक्वेशन को सॉल्व करने के लिए आप कोई भी मेथड यूज करेंगे, फाइनली आपको इंटीग्रल तो निकालना ही होगा. ठीक है, सो यू हैव टू बी ऑलमोस्ट एन एक्सपर्ट इन फाइंडिंग द इंटीग्रल्स ऑफ वेरियस काइंड्स. ओके, क्योंकि एक तरह का इंटीग्रल तो आएगा नहीं, बहुत तरह के इंटीग्रल्स आ सकते हैं. तो जितने इंटीग्रल्स के क्वेश्चन आप कर पाओ उतना अच्छा होगा. एनीवेज, ओके, so how will you solve this? This will be solved by what it's called integrating by parts. Integrating by parts. Okay, so this is the formula for integration by parts. Whenever you have two functions u and v, suppose of function x, okay, like we have this is one function, this is other function, and दोनों के प्रोडक्ट का इंटीग्रल निकालना आपको. देन जब भी इस टाइप का इंटीग्रल निकालना हो दो फंक्शन के प्रोडक्ट का, तो देन वी कैन यूज इंटीग्रेशन बाय पार्ट्स देयर. ओके, नॉट एवरी टाइम बट मोस्ट ऑफ द टाइम. सो वी ऑलवेज हैव टू रिमेंबर दिस फार्मूला. सो इसमें आपको ये मानना होगा कि u और v जो दो फंक्शंस होंगे जिनके प्रोडक्ट का इंटीग्रल आपको निकालना है, आपको बहुत केयरफुली एक को फर्स्ट फंक्शन मानना है, दूसरे को सेकंड. सपोज हम u को फर्स्ट मान रहे हैं, v को सेकंड. देन द फॉर्मूला विल बी फर्स्ट फंक्शन इनटू इंटीग्रल ऑफ सेकंड माइनस, इस ब्रैकेट के अंदर देखिए, माइनस डिफरेंशियल डेरिवेटिव ऑफ फर्स्ट इनटू इंटीग्रल ऑफ सेकंड, और इस पूरे का इंटीग्रल प्लस सी. ओके, आई रिपीट इट अगेन, फर्स्ट फंक्शन इनटू इंटीग्रल ऑफ सेकंड. सपोज यू एंड वी फंक्शन ऑफ एक्स है. ओके, सो फर्स्ट फंक्शन इनटू इंटीग्रल ऑफ सेकंड माइनस डिफरेंशिएशन ऑफ फर्स्ट इनटू इंटीग्रल ऑफ सेकंड, और ये जो आएगा इस पूरे का फिर से इंटीग्रल प्लस arbitrary constant. This is the answer. I mean, this is the integral of this. So in order to use this, इसको जब भी आप यूज करेंगे इंटीग्रेशन बाय पार्ट्स फॉर्मूले को, देन यू ऑलवेज हैव टू रिमेंबर दैट आप अपनी इच्छा के अनुसार फर्स्ट और सेकंड चूज नहीं कर सकते. ऑलवेज चूज दैट फंक्शन फर्स्ट whose derivative vanish after some time. Okay, I think here we don't need it. Okay, anyways, मतलब ऐसे फंक्शन को हमें फर्स्ट फंक्शन चूज करना है जिसका डेरिवेटिव हमें पता हो. ठीक है, बेसिकली इतना काफ़ी होगा. एनीवेज, ओके, हियर वी नो द डेरिवेटिव ऑफ बोथ. मोस्ट ऑफ द टाइम u को जो फर्स्ट फंक्शन है वो पॉलिनॉमियली चूज किया जाता है. ठीक है, इसको v चूज कर ली, इसको u, बिकॉज ये पॉलिनॉमियल है. सो दिस इज u हियर, this is v. So when we use this formula, we get this first function u integral of second minus derivative of u integral of second and whole सब पूरे का integral plus arbitrary constant. So integral of this will be minus of e to the power minus x, and when you use solve this, d by dx of 1 minus x will be minus 1 minus minus plus e to the power minus x is again minus, should be minus. Okay, fine. So ये की power minus x ही होगा because d by dx of this is minus 1 minus minus plus, so it becomes integral of this. So this will become integral of minus of e to the power minus x, which is this. Okay, so see, again simplify this, this e to the power minus x will be cancelled, this will give us this. So this is the value of, sorry, this is the general solution. On the left hand side we have this. So the final general solution is this, y into 1 plus x this, because यहाँ पे left hand side में ये था, we are multiplying both sides of the differential equation by e to the power minus x, sorry, we are multiplying by e to the power x, तो यहाँ पे ये e to the power x और e to the power minus x हो जाएगा 1, यहाँ पे x हो जाएगा और ये c के साथ e to the power x. ओके, so this is the answer. ये भी आंसर था अगर आप यहाँ पे लिखते कि this is the final answer. ओके, this is also the answer. So इस तरह के बहुत सारे questions हैं, you can see yourself. The most important step in while solving all these examples is the step when you start the integration. इंटीग्रेशन जैसे ही स्टार्ट होगा वहीं पे वही सबसे इम्पोर्टेंट स्टेप है. जैसे यहाँ पे ये है, आपको इसका इंटीग्रल निकालना है, तो ये तो आसानी है, कैंसिल हो जाएगा cos x. ओके, फाइनली वी हैव few more examples. Okay, for example see this, ये आपको पता होना चाहिए कि इंटीग्रल ऑफ 1/1 प्लस वाई स्क्वायर इज दिस, बिकॉज tan इनवर्स y का डेरिवेटिव 1/1 प्लस वाई स्क्वायर होता है. ओके, and when you use the formula for general solution this will give you this, and then आपको ये वाला इंटीग्रल निकालना होगा, and this can be used by using substitution, because tan इनवर्स y को अगर आप tan इनवर्स y को जैसे देखिए tan इनवर्स y को कुछ मान लो, tan इनवर्स y का डेरिवेटिव विद रिस्पेक्ट टू y ये है, सो tan इनवर्स y को कुछ मान सकते हैं u, या इन्होंने t माना है. एनीवेज t इज़ नॉट अ गुड नोटेशन बिकॉज t यूजुअली इज़ यूज्ड फॉर इंडिपेंडेंट वेरिएबल, है ना, और हम y तो डिपेंडेंट है, तो tan इनवर्स y भी डिपेंडेंट वेरिएबल होगा, तो डिपेंडेंट वेरिएबल के लिए ज़्यादातर हम u v यूज़ करते हैं. सो दिस इज़ नॉट अ गुड नोटेशन, u मानना चाहिए था. एनीवेज tan इनवर्स y को सपोज t माना, तो डिफरेंशिएटिंग बोथ साइड्स दिस विल गिव 1/1 प्लस वाई स्क्वायर डी वाई इक्वल टू डी टी. तो 1/1 प्लस वाई स्क्वायर डी वाई हो जाएगा डी टी, और ये हो जाएगा e की पावर 2t, तो ये ऐसे बन जाएगा. तो सब्सटीट्यूशन मेथड से ये हो गया. एक और चीज़ आप नोट करेंगे कि इस वाले क्वेश्चन में y इंडिपेंडेंट है, या y इज़ इंडिपेंडेंट, बिकॉज ये थोड़ा सेकंड टाइप का डिफरेंशियल इक्वेशन है. रिमेंबर इस टाइप की डिफरेंशियल इक्वेशन मैंने देखी थी, dx by dy प्लस p which is a function of y alone and q which is equal to q which is a function of y alone. इस टाइप का डिफरेंशियल इक्वेशन है ये. देखिए इसमें y इंडिपेंडेंट है, x डिपेंडेंट है, इसलिए जब आप इसमें ये वाला फॉर्मूला यूज़ करोगे जनरल सॉल्यूशन वाला, उसमें आप x डिपेंडेंट रखेंगे. रिमेंबर डिपेंडेंट वेरिएबल इनटू इंटीग्रेटिंग फैक्टर इज इक्वल टू इंटीग्रेशन q इनटू इंटीग्रेटिंग फैक्टर dy, बिकॉज y इज़ इंडिपेंडेंट, तो इसलिए dy आएगा प्लस c. So this will be the formula for general solution in this question. Okay, बाकी तो मैंने खुद सॉल्व कर ही रखा है. उसके और भी क्वेश्चंस हैं, ये you can see it yourself. ये है. Okay, practice. Then we have this, and we have this. Then we have some exercises here. And answers. 20 exercises are given at the end of this chapter, and all the answers are also given. Well, this is one of the good things of this book, that most of the examples are solved already for you, so you don't need to solve them yourself. But at the end of the chapter they have also given you pretty good exercises, okay, and not just the exercises but also the answers. You will find that in many books the exercises are given but the answers are not given, और they give the answers for odd questions only. बट यहाँ पर आप देखेंगे सारी एक्सरसाइजेज जो आपके लिए अवेलेबल हैं उनके आंसर्स भी दे रखे हैं, so that you can match your answer. Otherwise how will you know that your answer is correct or not? Anyways, so this was all about linear differential equation of first order and first degree. So let me give a quick summary for you. This is the differential equation of first order and first degree where y is independent, y is dependent and x is independent. P's and q are functions of x alone, or p and q can also be constant, okay. q की जगह पे कोई कांस्टेंट हो सकता है, p की जगह पे भी कोई कांस्टेंट हो सकता है, okay. And the general solution is given by dependent variable into integrating factor is equal to integration of q, this q, into integrating factor into dx plus c. C is the arbitrary constant. This is the general solution of this differential equation where integrating factor is given by e to the power integration p dx. This is p. This is all about. Fine. Thank you very much.